The arts and sciences have been disconnected professions. The physicist and popularizer of science, J.D. Bernal, once explained this separation. Science, he said, was used to make the money. Art simply as a means to spend it. In the past, artists and scientists were dependent upon each other, often working as both scientists and painters. And surely Leonardo would have agreed with John Constable that painting is a science and should be pursued as an inquiry into the laws of nature. And here in the micro gallery of the Sainsbury wing, the arts and sciences converge. Here the general public can touch these screens to find out more about the paintings upstairs. And increasingly this computerized catalogue depends on the daily collaboration of art historians, conservators and scientists. In this video, we're going to take you behind the scenes to show how science is used in the conservation of works of art. Paintings are fragile objects. To preserve them in the best possible condition, we need to understand what methods and materials have been used by their creators. In the last century, picture restorers had few scientific aids other than the magnifying glass. Today, all that is changed. National Gallery conservators are fully supported by intensive scientific research. The analytical methods and equipment used in the scientific department monitors the museum environment, measures changes in the condition of the paintings in the gallery, identifies the materials used by the artists, and may even throw light on the authorship of our master paintings. Beginning with the naked eye of the art historian, we're going to show how different sorts of information can be extracted from the many layers of a painting using the tools of modern science. However, the scientific department can only investigate paintings already in the care of the National Gallery. But in the case of pictures being considered for the collection, it is not possible to analyze the paint or reveal the hidden underdrawing. So, unaided, the eye of the museum curator has to assess the authenticity and the quality of potential purchasers. I asked the director, Neil McGregor, how this process worked. What was, for instance, connoisseurship?
If you look a lot at an artist, you notice that he will tend to group figures in space in a certain way. He'll tend to use color in a certain way. He'll do little details in a characteristic shorthand way. And by looking a lot at the work of one artist, you can then, when you look at a new painting, decide whether or not it's by him. That's what has always gone on when the gallery decides whether or not to acquire a new picture. And that's what goes on today. The only difference is that today, there's a chance after we've made that decision that we can very quickly find out whether it was right or wrong.
In 1987, the gallery took a gamble and bought at auction this previously unknown picture, supposedly painted by the German Romantic artist Caspar David Friedrich. It was the presence of a very distinctive underdrawing, revealed by scientific investigation, that confirmed the art historian's opinion that it was indeed by Friedrich. This preparatory underdrawing was made visible by the detection of infrared radiation reflected from inside the picture, a technique known as infrared reflectography. This camera is now pointing at a landscape by Solomon van Ruysdael. The camera is sensitive to the infrared radiation bounced off the white base layer of the painting and absorbed by the black underdrawing. Examination by this infrared Vidicom television system gives immediate results. The infrared radiations are translated into clear images of the underdrawing viewed on the monitor screen. Conservator David Bomford explains the importance of the infrared Vidicom system.
The invention of this technique some 15 years or so ago gave art historians a completely new weapon in attribution. Now you can not only look at painting styles, but you can also look at underdrawing styles as well. And you can compare them where relevant with known drawings by the same artist.
Infrared radiation lies outside that part of the electromagnetic spectrum visible to the human eye and can penetrate the structure of many pictures down to the lowest layer or ground. This ground or priming layer may be either lead white for traditional painting or before the 16th century, gesso, an inert white powder mixed with warm animal skin glue. To be detectable, the underdrawing does need to be made on a white surface with charcoal, graphite, ink, or any paint containing carbon, the chemical element that is picked up so distinctly by this technique. This oil painting was one of many river scenes made by the Haarlem artist Solomon von Ruysdael, some on canvas, others on panel. This one, probably an imaginary view, has been painted on a panel of oak, prepared with a chalk ground. David Bomford again.
If we want to look at a slightly different area on the painting, we can move across or up and down. And so by moving the picture like so, we can examine the area above the bridge and see these extraordinary spirited loops of foliage that he put down on his panel to show the trees that were to be just above the bridge. It's interesting that the figures who are standing on the bridge in the finished painting were not drawn. He actually put those figures only in at the last stage when he was doing the painting. He didn't plan them at the drawing stage.
X-rays, electromagnetic radiations at a higher energy level than infrared, are extensively used for the examination of the whole picture. Infrared radiations pass only through the upper layers of paintings, whilst X-rays penetrate the complete sandwich of paint film, ground and support, be it canvas or wood. This enables the conservator and historian to have a composite image of every stage in the making of the painting. When the Spanish painter Goya exhibited this painting in Madrid in 1805, nobody would have known that Donna Isabel de Porcel had been painted on an already used canvas. But Goya had made this likeness as a kind of thank you for hospitality, and perhaps wanted to surprise his hostess with this vivid, unpremeditated portrait. Pigments absorb X-rays in different degrees, depending on their component elements. Those containing heavy metals, such as white lead carbonate and red mercuric sulfide, called vermilion, which are both used in skin tones, are highly absorbent and show up white on the X-radiograph. But the earth colors, browns, blacks, are less absorbent and therefore less easily detectable by this particular method. The X-ray of Goya's painting reveals a not unusual practice, that of working on an already used canvas. But when this 15th century panel painting by Giovanni da Paolo was X-rayed, this is a black and white photograph taken before conservation, a rather more complicated story was revealed. Although the two figures are somewhat obscured by the shapes in the wooden panel and the long nails driven into the sides, it is possible to detect a greater number of arrows in the figure on the right than appeared in the photograph of the unrestored painting. The naked figure, punctured by arrows, is Saint Sebastian, a Roman officer discovered to be a Christian and later sentenced to execution by his own archers. Sometime before the painting was acquired by the gallery, in 1911, a restorer had improved the rather naive drawing by adjusting the outlines and editing out some of those arrows, Because of these corrections, scholars were undecided about the authorship of the panel. Once it was restored to its original state, with triple the number of arrows, there was no longer any doubts over its authorship. For the majority of analytical techniques, a microscopic cross-section needs to be removed from the painting undergoing conservation. The condition of paintings as old as these varies. The surface may have been damaged in the past by church candles, or attacked by mold, or weakened by the faulty technique of the painter. During the conservation process, a tiny fragment is detached from an area of damage, or from the edges, where they're normally covered by the frame. A surgical scalpel detaches the sample, which is then transferred to a numbered gelatin capsule with a soft brush. Each sample is logged and recorded on a photograph. We mentioned earlier that certain pigments, when applied thinly, do not show up on radiographs, but a technique known as X-ray diffraction, or XRD, will distinguish these and other pigments with great precision. Many artist colours are crystalline in form, and when photographed by an XRD camera, their individual structure can be accurately identified on photographic film. Gallery scientist Aviva Bernstock is preparing a tiny fragment of a picture for X-ray diffraction analysis.
What I do is I find a small pure sample of the thing that I want to analyse by X-ray diffraction. I check under the microscope that I've got a pure sample, and I cut it to the right shape. And at this stage I need to mount it up in the X-ray diffraction camera at the end of the cat's whisker. Now it's inside this. Put a spot of the glue at the end of the brush, and then mount the sample long ways at the end of the cat's whisker. And then I carefully take the mounted sample and place it in the X-ray diffraction camera. Now the next thing to do is to align the sample so that when the X-rays pass through here in the X-ray diffraction setup, they hit the sample, which is perfectly aligned with these two holes. And at this stage, I take it into the darkroom so that I can put in some X-ray sensitive film around the outside. Right, that goes in like that. And now we can mount it.
The camera is mounted on the top of the machine, and for 2.5 hours the sample turns slowly, presenting as many faces as possible to the narrow beam of X-rays. The regular pattern of stacked atoms in each sample scatters these X-rays into a unique configuration recorded on the film. The X-rays are deflected by the atomic layers in the crystal, mapping out complete circles, but for the purpose of identification, it is only necessary to record a narrow section, rather like end grain on a plank of wood. The sample being analysed can be identified by comparing with known standards or by measuring the individual patterns of the bar lines. To examine the cross-section of a painting, it is necessary to embed the fragile sample in transparent polyester resin. A tiny fragment is placed in a half-filled silicon rubber mould, then covered by fresh resin and put aside to harden overnight. The hardened blocks are then ground in various stages. After the final polishing on this machine, the sample is clearly visible, embedded in the clear resin.